I want to jump right into our next section, which is going to be section 2.2, and we're going to look at this concept called the limit of a function. So we are leaving for a little while the tangent line problem. Right? How do you get an estimate, and eventually how do you get the exact value of the slope of the tangent line? And what we're moving on to now is a concept called limits. And we need this concept and we need to understand it and be able to work with it in order to later on return back to the tangent line problem and come up with an algebraic way of finding the exact value. And this algebraic way of finding the exact value of a slope of a tangent line is going to involve limits, right? It's going to involve you calculating things that we call limits, right? So that's for there. Here is a function, and it's definitely broken apart. It would be some messy piecewise function, but we're using it to get to show you that there are in fact three types of things called a limit. One is called the overall limit, and it's written like this. So you might say, what is the overall limit as x tends to 3 of this function? Then we have a thing called a right limit, and you would say it out loud as, what's the limit as x tends to 3 plus of this? And then we have a left limit, which is, what is the limit as x tends to, 5 minus of this function f of x? So let's figure out what we mean in mathematics by what a limit is. Right. In a very non-mathematical way, at least as non-mathematical as I can say it, the limit of a function, let's call it y equals f of x, as x approaches a value, let's say as x approaches 3, is value that the function is trying to reach as you get closer to, say, x equals 3. Now, limits to me are a very visual thing. So that sentence might not mean a lot to you, but let me show you a picture and it might mean something a little bit better. Let's suppose we have a little function, right? And essentially there's a problem x equals 3. And the function goes like this. There's a hole at 3, essentially, right? Now, the value of the function is essentially going to be whatever that number there is. And let's say that number is 7. So when we say that the overall limit as x tends to 3 of this function, when we say it's equal to 7, would you agree as you get closer and closer to x equals 3, isn't the value, the y value, getting closer and closer to 7? The problem is at x equals 3, isn't there a hole? In other words, the function for whatever reason is undefined there. Now that can happen when you have, do you know how you have a fraction where the top and the bottom cancel out, but there's still a problem at 3 because at 3 you have 0 over 0, right? Whatever the reason is, this can happen. And so when we talk about the overall limit as x tends to 3 is 7, we're saying this is the value, the y value, this function is trying to be. Okay? That's essentially the gist of what we want. Now, what can make this complicated is that you might have a dot up there, right above 3. Do you see that dot there? And that dot, let's say, is at 12. So the value of the function at 3 is this guy here. Do you see that the limit and the value don't always, and probably most of the time in these questions, are not going to be the same? Right? The value of the function is where this dot is. So somebody says, what's f of 3 equal to? You would say it's equal to 12, right? That's the height, y coordinate. But if I said to you, what's the overall limit as x tends to 3, wouldn't it be that guy? In a lot of ways, isn't 7 more reasonable than the 12 is? Couldn't that 12, that dot there, be put anywhere? It's kind of random, isn't it? But wouldn't the 7 be what we've got? We even have names for different types of situations like this. This particular one is called a removable discontinuity, which you'll find we'll talk about later, but we don't need to know it right now. Are we comfortable with what I mean then when I say the overall limit of a function is x tends to 3? It's what the function is trying to be, not necessarily what that dot is. Now, sometimes that dot won't even be there, right? Try to hide it with a pen now. Sometimes that dot's not even there. In that case, won't the overall limit still be 7? It doesn't care if that dot's there. If it is there, it still doesn't care. It's still 7. Do you see that the overall limit is not affected by that individual random spot in the function, right? It's not influencing. Now, if that dot was missing, wouldn't the value of the function now be undefined? Right, f of 3, the value of the function is undefined, because at 3, there is no value, agreed? So try and separate the value of a function from its overall limit. They are very often quite different from each other, as you can see in the two situations that I have. Now, if you want to do what's called a left and a right limit, you just refine the idea. And so let me use this guy here to kind of show you what's going on. Let's take a look at x equals 5, right? What's happened to this function at 5? Well, the first thing I can tell you is that this answer here does not exist. There is no overall limit, because as you get closer to 5, doesn't it depend on which side of the graph you're talking about? As you get closer to 5 here, isn't the answer 5? But as you approach from this side, it's 10. We have names for these two particular versions. They're called the right limit and the left limit. Let's show you a right limit. If I wanted to find, I guess I'll put this over here again because I need some space. Let's suppose I wanted to find the left limit. So the left limit would be written down as a limit as x tends to 5. And if you're coming in from the left-hand side, it's called 5 minus. Essentially, aren't you coming in from the 4.99999 side, right? As you get closer to 5, you're always doing it on the left-hand side of 5, right? 4.999, 4.999. Well, if you were looking at this graph here, the left limit would be there, where my finger is, and it is 5. Now, if I asked you to do what we call the right limit, it's called the left. This one's called the right of this function, right? We're approaching 5, but we're coming from this side. Well, as you get closer and closer to x is 5, the function is 10. Which means that the overall limit does not exist. For an overall limit to exist, shouldn't the left limit and the right limit both be the same number? They both should be 10 or 22 or whatever it happens to be. But if one of them's saying I'm trying to be 5 and the other one says, no, I want to be 10, there is no single answer anymore. That means the overall limit does not exist. Now, in this question, based on this picture, what is the value of f of 5?
Ten.
Yeah. Isn't it where that little solid dot is, if it has one? Now, this happens to belong to this guy here, but that doesn't really matter. It happens to be 10. Okay, let's look at what's happening at 10 then. And I'm going to do the limit as x tends to 10 plus. I'm going to try and evaluate the limit as x tends to 10 minus. And then we'll see if the overall limit exists. And then we'll see what I ask after that. Right, left limit, 10 plus. Oh, we have names for this. When you come in from this side, this piece of the curve is called the right branch. And this piece here is called the left branch. It's just a name for it. Right, so 10 plus, I'm coming in from the 10 and bigger side. So I'm getting closer and closer, and the answer is 4. Now, if I'm doing the left limit, I'm coming in from the left side. And as I get to x equals 10, yep, the function's trying to be 4. So what would the overall limit be as x tends to 10, which is this one?
It'd be 4.
It'd be 4. So if you want to find out, limits, don't you probably find the left and right first? And if they agree, the overall limit is equal to that number. And if they disagree, the overall limit is you do not exist. Now let's figure out what the value of this function is at x equals 10. Does this function have a value at x equals 10? Which means it does not exist. Notice the value of the function doesn't necessarily fit with the limits, right? This one doesn't exist, but all these are equal to 4. And this one had a 5 on one side, a 10 on the other. The overall didn't exist, but the value of the function at 5 is 10. Okay, let's make this last one a little bit easier. The third one in my picture would be as x tends to 15, right? Does that have an overall limit? Visually, can you just see that that doesn't have an overall limit? If you're going to have an overall limit, don't they have to meet in the middle? They have to look like this. And that's called a removable discontinuity, if you want to know its name. If they don't meet in the middle, doesn't that mean the overall limit doesn't exist? Of course, you'll have a left and a right. They will exist. And here you have a left and a right. These are called jumped discontinuities, if you're interested in the names. Are we getting a little bit more comfortable about a left limit, a right limit, and an overall limit? Because that's what that's the concept we're trying to get through here, right? What is the left limit of this function? Very often you're given pictures, right? What's the right limit? What's the overall limit? Maybe even what's the value of the function? Okay, so I'm now going to, oops, hopefully, we'll see. Yes. Now going to move over to WebAssign because they have some questions and I can use them. Saves me having to draw pictures. And here we go. Maybe make this thing a little bit bigger. Okay, here is the function, the red graph, and below they have a whole load of questions. I'm just going to randomly pick some, just make sure that we're cool with the concept. For this curve, does the overall limit as x tends to 2 exist?
Nope.
No. Agreed? Piecewise function. Right, as x tends to 2, there's a problem, right? It's broke. What would the left limit as x tends to 2? So that would be 2 minus.
3.
Agreed. What's the right limit going to be?
1.
1. What's the value of f of 2?
3.
Are you getting comfortable now? Value of the function, left limit, right limit, overall limit. There's only one more in this question, so what's the overall limit as x tends to 4?
4.
Yes, it's where that little hole is, it's 4. What's the value of f of 4?
Does not exist.
Does not exist. Yeah. I think hopefully the more of these darn things you see, the more comfortable you could be. Okay, this one doesn't have much going on it, but what's the limit as x tends to 3 minus?
1.
3 plus. What's the limit as x tends to 3 plus?
4.
4. Does the overall limit exist in this picture?
No.
No.
Move on. Oh. I'll just mix and match these questions. What is the overall limit as x tends to -3?
4.
Agreed. Right there, 4. See it? What is the right limit as x tends to 0?
-1. Or, sorry, 1.
No, you were right.
Oh, -1.
Correct, -1. You
My bad.
got me guessing there. I think I said 0 plus. If I did, it is -1. What would the limit as x tends to 2 minus be?
2.
And limit as x tends to 2 plus?
2.
So what would the overall limit as x tends to 2 be?
2.
2.
And what's the value of f of 2?
Does not exist.
Right, we're getting faster. I think we're getting faster, right? So that means we're getting more comfortable. Right, left limit, right limit, overall limit, and what's the value of the function, right? That's the typical things you're going to be asked.
So
Yes,
for this one, for when you said value of 2, is it does not exist because the circle is open, or
No. It doesn't exist because the left limit, the value of the function. Oh, let's see. When I said f of 2 does not exist, is that the thing? Yeah. Right.
Yeah,
Do you
sorry.
see the little hole at 2?
Mhm.
Right. There isn't any dot above it or below it. If there was a solid dot above it, the value of the function would equal what height that dot was in. Right. So if there was a dot up here where my mouse pointer is, hopefully you can see my mouse pointer, right? Let's say there was a dot there. F of 2 would have been 5. And if there was a dot down here, f of 2 would be -1. But if you look at x equals 2, do you see that all you have is a hole and nothing else? That's why the value of the function doesn't exist.
Okay. So that dot is expressing an undefined value, or
No, the dot is actually doing the opposite of that. It's telling you exactly where the value of the function is at that one spot. So a dot, the x equals 2, if there was a dot anywhere, that dot is representing the value of the function. Let me nip out of this and show you one of those dot things. Hopefully a little bit clearer.
Professor, would
See
you
that-
say a solid dot would be
Yes.
inclusive and a open circle is exclusive?
Yeah, how about that?
oh,
That
okay,
help?
okay, yeah, that makes sense. All right.
Good, gotcha. I was just going to say, look, there's an example of the dot I'm talking about, right?
Mm-hmm.
This function here, the value of the function at 15 would in fact be 10, right? So, are we getting comfortable? So let's make you uncomfortable, because you have to do that as well. So we can return to this one. there's a big problem at x equals 5. I'm not sure how much more zooming in I can do. There, one more zoom in. Would you agree that x equals 5, this function is doing some really weird stuff? So we have to figure out how the idea of a limit can be, how it works in these situations. So I'm going to make an executive decision here. At this point here, right, see this curve that comes down? Oh, by the way, can you see my mouse pointer when I move it? Because, oh God, thank goodness. Right, as you go along the right-hand curve, would you agree that it gets to here? I'm going to make the assumption that it definitely gets to here on the right-hand side. So that would be the limit as x tends to 5 plus is 3, right? So the limit as x tends to 5 plus, right, a right-hand limit was 3. Now, how am I going to deal with this ziggy-zaggy thing? I'm going to make the assumption that this function does a really weird thing. It goes up and down like a sine function, but as it gets closer and closer to 5, it never actually gets to 5. Can you imagine it just goes infinitely up and down? Each time it gets a little bit closer, but never quite gets there. And it goes up and down. Now, a function like sine of 1 over x would do that. If you want to see sine of 1 over x, it looks really weird when x gets to 0, right? That would be an example. So I would say that this function, the limit as x tends to 5 minuses, it does not exist.
How come there's no open circle there?
A good point, don't know.
Yeah, that's what threw me when I did this one on the homework. Yeah,
It would have helped, probably.
Yeah, it would have helped a lot.
Yeah. Yeah.
But when it covers squeeze theorem, it kind of makes it kind of makes it make sense of why that's like that, because continuously oscillates indefinitely.
Yes, it's this idea of like a concertina that's being crushed infinitely often, so it cycles, essentially goes on forever. And I think we're good with that one. This one's nothing special, so I won't pay any attention to it. Now we are now moving, I'm going to have to shrink this, to left, right, and overall limits involving vertical asymptotes. Remember fractions from 141, vertical asymptotes. Now, normally you would probably say things like it doesn't exist or it's undefined. And we're going to change that world. You are allowed to have an answer of plus infinity. You're allowed to have an answer negative infinity. And you're also allowed to have an answer does not exist. So let's see how that works. Let's take x as negative 3. You see this guy here? X is negative 3. Now, as you approach from the left-hand side, the function goes up to infinity. So we would say the limit as x tends to negative 3 minus is plus infinity. And then if you come in from the right-hand side, also plus infinity. And so the overall limit at x equals negative 3 would also be infinity. And I've just realized that I'm saying too much and not writing. So let me show you a little picture. I like pictures. Let's suppose this is our vertical asymptote, right, at 3. And this is the function going up this way, right, and it's coming up that way, right? If I asked you to find the limit as x tends to 3 minus, that's the left limit. If I then said, find the limit to 3 plus, it would be that. If I then asked you to find the overall limit as x tends to 3, you'd write it like that. Right, now I can do my fingers and point. As you come in from the left-hand side, isn't this function zooming off to infinity? Positive infinity, right? Upwards. Now, if you come in from the right-hand side, right, the 3 plus side, also shooting up to plus infinity. And isn't the overall limit here infinity? Suppose we have another vertical asymptote over x equals, I know, 7. And this function does this. Right, this guy's 7. Same 3 questions. A left limit. The right limit. And finally, an overall limit. Okay, cover that up because it's a distraction. The limit as x tends to 7 minus means you're coming in from the small side, right? You're coming in from the left. Would you agree this zooms off to infinity as you get closer to 7? If you do it from the right side, like coming in from this side, doesn't it go to negative infinity? What will the overall limit be if the left is this and the right is that?
Don't
Does
exist,
not
right?
exist.
Doesn't exist. Isn't it the same rule as when numbers? Doesn't the left and right limit have to be the same thing? Right, we'll just call it thing. The same thing for an overall limit to exist. Does that make sense? Now, if you think about vertical asymptotes, there's not that many different shapes to them. Don't you get the ones that look like a volcano? You get the ones that look like a hole in the ground. And then you get the one of each, right? It goes down this way and up that way. So there's not that many permutations, right? So there's only so many answers that you're going to get. But if there's a vertical asymptote involved, won't the answer be plus, minus infinity, or does not exist, right? Depending on which limit you're going to be asked. So now let's return back to that question and look at it. Maybe it'll make a little bit more sense. Okay, what is the overall limit as x tends to negative 1?
Negative.
See, negative infinity. Yes, Robert. So your lips move. What would be the overall limit as x tends to 2?
Does not exist.
Does not exist. Is it pretty easy? Actually, in a lot of ways, aren't vertical asymptotes easier to deal with? Because you only have a few answers. Plus infinity, minus infinity, or it just doesn't exist.
On
Okay.
asymptotes, can you have one of those solid circles where the asymptote is?
You could, somebody could put a dot where my mouse pointer is, right? A solid dot, right?
All right.
And if they did that, the overall limit would still be plus infinity, and the left limit and the right limit would still be plus infinity. The only thing that would change is that
Absolute
isn't the
value.
value of the function actually exists now. So f of negative 3 would be 1.
All right.
Normally, when you don't have that, isn't the value of the function undefined or does not exist, is what we're going to use.
Yeah.
So if I said to you, what's the value of f of 2, you would say, does not exist. If I said, what's f of negative 1, doesn't exist, and so on. Right, here's the guy. Let's change the question, turn it on its head. On this diagram, on this function, where is there an overall limit that's plus infinity?
0.
-3 and 0.
Agreed. Where is there a limit, an overall limit, that is negative infinity?
-7.
Right. If I asked you to find the limit as x tends to 6 plus,
Does not exist.
6 plus,
Positive infinity.
positive infinity, right?
Uh.
6 plus. Now, if I'd said the limit as x tends to 6, that would be a does not exist. Agreed? But a 6 plus is a right limit, a 6 minus is a left limit. They do exist, right? In vertical asymptotes, you're going to get something from those two. the overall limit might not exist. Now, before we move on, let me try this situation, which I don't think they have an example of it, which is a pity because it would be nice if they did. I'm going to put a vertical asymptote at x equals 5, but I'm going to do something a little bit different. Right, so there's a weird looking curve. It's got a bit of a vertical asymptote going on, right? Part of it is vertical asymptote, but isn't the other bits not vertical asymptotes, right? They're just pieces of a piecewise curve. So let's do a limit 5 minus. Let's do a limit 5 plus. And lastly, well, not lastly, because I have one more thing after this, an overall limit. And then lastly, that guy. So there are 4 things we're going to be asked. Based on this graph in front of us, what is the limit as x tends to 5 minus?
Plus infinity.
All agree? Coming in from this side, right, shoots off into space. What is the limit as x tends to 5 plus of this thing?
One.
1.
Yeah. Don't let the vertical asymptote distract you. In fact, as far as 5 plus is concerned, there's not a vertical asymptote there, isn't it? As far as its world's concerned, it's just heading towards x equals 5, right? It doesn't care what's happening on the other side of 5, right? It's only what's happening, you know, on the right-hand side. Overall limit in this question.
Wait, should he?
You're breaking up, Matthew, so I'm not quite sure what you
I
said.
agree with him. Yeah.
Oh, you heard what he said. Can you tell me what he said so I can write it down?
No, I don't know what he said. But I do
Oh.
agree.
You're just being a pain in the butt, aren't you? Right. Okay, that's my job. Anyone, what would the overall limit in this question be?
Does not exist.
Yeah. The answer to all overall limits is simple. If these 2 things are the same, the overall limit is whatever these 2 things are. If these 2 things are different in any way, then the overall limit does not exist. Now, to finish with, what is the value of f of 5 in this question, this graph?
2.
2.
2. So you can see in this one picture, aren't all of them different from each other? It depends on what you're asking, what the response should be, right? A left limit is not necessarily going to be the same thing as the right limit. The overall limit could be, does not exist. The value of the function might be there and might not be there. So far, so good. Any questions before we move on to using Desmos to answer some of the same kind of questions? Okay. I had my little list here, now I have to go hunting for it. Okay, here we go. We are going to look at graphing a piecewise function in Desmos. And it took me about 15 minutes just before class started to remind myself how Desmos does it. So let me show you the function that we're going to do. Let's have a function f of x And if it's been a while since you've seen a piecewise function, they might look like this. And this function is going to be equal to x squared plus 1 if x is less than or equal to -1. It's going to be 2x if x is between -1 and 2. And it's going to be just 3, so it's a constant value, if x is greater than or equal to 2. So that's probably one of the more complicated piecewise functions. Typically, you're more likely to see just 2 pieces, right? A left and a right, but here we have 3 pieces. And our job is to sketch this thing. Now, if you try to do it by hand, you could do it with a table of values, but it would definitely be a problem, right? It'd be hard to do. So I'm going to show you how you do it in Desmos. Here we go. So if you're not used to Desmos, this might be useful. Let me just cover that guy up. Actually, let's delete that guy as well while we're at it. Right, so I'm just keeping that guy there so I can remember the format. It's going to be y equals, you do one of those little curly brackets, and the first function I had was x squared plus 1. And I'm glad I kept the little format there. And you put x less than or equal to -1 first. And then you do a colon. And you finish with a little curly bracket. So y equals, kind of back to front, but you put the restriction first. Maybe I should zoom this in just for a minute so you can see there. Maybe just so you can see how I typed it, right? In this case, there's your restriction. A colon followed by the function. So if you rub this bit out, wouldn't it be y equals x squared plus 1? Right, that's the function. Right. So what you then do, I can make that go away. You take the second one. I'll just copy this for speed. And this one was -1 x less than 2. So our restriction is going to be from -1, too many of those guys, from -1 to 2. And the function was just 2x. Probably would have been easier just to write this from scratch. Right. So there's the restriction. There's the restriction. Colon the function, which in this case was just 2x. And then the last one, y equals, curly brackets, x greater than or equal to 2. So for x values greater than or equal to 2, you're going to use the function 3. And I'm now going to shrink this back and zoom in. There. Now, can you see the piecewise function a little bit clearly? Can you see it's really got 3 separate bits to it? Now, the boundary changes were at -1 and at 2. So what I'm going to do now is find out where those solid dots go. Remember, there was a solid dot if the function is equal to that. So these endpoints, if I have a dot there, it means that's the value of the function. If there's not a dot there, can you think of an open circle being there? So according to this piecewise function, when x is -1, you use x squared plus 1, which is 2. So that would be the point -1, 2. So what I did is I evaluated the function at x equals -1, and I got 2. Do you see where the dot is? Belongs to that curve now. Now, there was another boundary point And it was when x was greater than or equal to 2, then you use 3. So that means when x is 2, you then use a value for 3. And there's your dot. And I'm just going to zoom in here to the important part. There we go. Can you see the dots are there now? See this line here? Will you imagine there's an open circle? Now, there might be a way to make Desmos do that. That's your piecewise function, right? So, solid dot, open circle, open circle. So I should be able to, or we should be able to answer questions now about left, right, and overall limits. So let's do the -1. What is the limit as x tends to -1 minus? That is the left limit.
2.
Correct. -1 plus, which is the right limit.
-2
-2.
Overall limit.
does not
not
exist.
exist.
Value the function at -1.
2.
2. Right, see, isn't everything there? You just had to make the picture now. That's like the next level, right? We gave you the pictures at the start and then we asked you those same kind of questions. Now you're going to have to go into Desmos and draw your guys, right? And that's, you know, an added level of work that you need to do. Now, what does that look like when you, let me find the right page for you. What does that look like in your homework? Well, it looks something like this. I'm going to shrink this way up. Here is the function that they're talking about. You see it, that one? Here are 4 pictures. If you, mine is different, right? This is not the one I did, right? This is theirs. But if you did this in Desmos, can you see one of these 4 pictures would be the guy you'd get? And let's just pretend it was that one. Okay, now the next question is not left limit, right limit, or overall limit, which would be nice. It is for what values of this function. Let's get this right. Use the graph to determine the values of A for which this overall limit exists. And it's telling you that the answer is going to be in interval notation. So let's just assume that this was the graph. If I said to you, where does the overall limits exist? Wouldn't it be easier for me to say, where does it not exist? Because pretty much every single point on this curve, won't the overall limit exist? Right. The only place there's a problem is at 0, agreed? So when they talk about use your graph to determine the values for which it exists, you're basically going to say everybody except x equals 0, and you're going to have to give your answer in interval notation. So let me show you what that guy looks like. So hopefully it'll take my bracket, and it will take negative, and I'm going to go hunting for infinity, comma, 0 in this case. Then you remember that union symbol? I know it's a long time since you did it. It looks like a big U, right? So let's go hunting for that. I think it's here. Union, a bracket, 0, comma, and then keep hitting them often enough, I'll get the guy I want. And there you go. So your answer to the question, for what values of A does this function overall limit exist? You're basically saying everybody except 0. But in interval notation, that's how you would write everybody except 0.
Make sure that when you guys do this, that you don't put typos in like I did and then go, oh, how did I get it wrong? Because it eats up one of your answers.
Good advice. Now, I believe, I'm going to check this out. So let me rub this out. I believe you can do this. you can type in the word infinity and it will just do infinity for you, right? I don't know if that is worth much, but it is. You can actually type in pi, pi, and it'll do pi for you. So if you don't want to go hunting for, where's that infinity symbol, just type in infinity and it'll automatically turn into an infinity symbol. And then if you want to make it negative, just click to the front and, put in your negative yourself.
If it was our previous answer, but the right side of the union, instead of a 0, it was a 5, would it mean that it's all numbers except 0 to 5?
Oh, I'm trying to think which one we've got here.
We had negative infinity 0, union 0, infinity. But if the second 0 was a 5, would it mean every number except 0 to 5?
I'm not sure. I don't want to say yes to that because I'm not sure. I'm trying to find if it came from this guy. Okay, now I've got the picture in front of us. I'm going to look at what you were saying and how we would write the answer to this question, right? So suppose they said, for what values of A is this function's overall limit exist? Would you agree it has a problem at 5?
Yeah.
Now, that would be negative infinity to 5, union 5 to infinity. And you see how they're curved. That's essentially everybody except x equals 5. So that's
So
the
now
answer.
say the first 5 was a 0. Would it say everybody except all the numbers between 0 and 5?
If the first 5 was a 0, I'm not
I
sure
think
what you mean.
I think he's referring to the jump. If the asymptote is at 0 and the next value for the function begins at 5, so
Yeah.
from 0 to 5, there is a giant open space.
Yeah, there's nothing there.
Ooh, yeah, I gotcha. I think I gotcha. Try to pick another color.
Sorry.
Red's got the job. So suppose it was like that, and this thing here just wasn't here, right?
Yeah.
Then you would be looking at negative infinity up to 0, union 5 to
Okay.
infinity.
Yeah, that's exactly what I was saying.
And that would be correct.
Okay. I was wondering if that was just possible at all.
It was. I mean, you can have a function that's just missing. There's no function there for whatever reason between 0 and 5. That's not as strange as you might think. I mean, if you take a function that looks pretty something like that doesn't look particularly weird. If you sketch that function, it actually looks like this. There's a big gap in the middle where the function doesn't exist. Actually, I think I got that the wrong way around, but it essentially x squared minus 25. So it is possible. Yes. Interesting question. Okay, so are we comfortable with this next level where you have to use Desmos to draw your thing? And you'll get better at it. If you're used to Desmos, you're good. If you can't remember what I did, can you go back and watch that little piece of the video where I typed it in? And that'll tell you. So let's make sure that I'm looking at the right thing. Here we go. Question 9 is essentially the same question, isn't it? Do a piecewise. Evidently, it's going to be one of these guys. And then just tell me the interval it works with. Keith, you've already done that. Did these come out pretty good?
Yeah, they did. Some of them were a little bit difficult to work through, but I finally figured it out.
Okay, so if we go to 10, do you see that the function's not piecewise anymore? It's just an ugly function. But it's probably got some weird stuff going on. That's why they picked it. But, well, we got this guy. We got this fella here. Do you want me to do a version of, say, 10 or 11, or are you comfortable with just plugging into Desmos and see what you get? It's up to you, look. What do you want me to do? You fine?
Yeah, I have no idea what I'm looking at there.
Right.
Wait,
But
sorry.
when you say that, you can see question 10, but you've no idea what it would look like as a function. Is that what you're
Yeah,
saying?
yeah.
Okay, let's show you what that thing looks like as a function then. Because I've got too many windows again. Here we go. Hold off that thought for a moment. I'm trying to get the right windows up and then I should be fine. No, the guy that I want to see is getting hidden by Desmos because Desmos has been a pain in the butt. Let's try again. That's this fella. There we go. Okay, so the function I'm going to do is question 10. I'm just writing it down and then I'll go into Desmos and we'll see what we see. Okay, so make all that stuff go away. And we just type it in as we see it. Y equals. Now, you can just go and click this guy and get the square root symbol. Or I believe you can do SQRT for short, and it gets you the square root. And the guy we have is a 5 plus x to the power of -2. Pretty weird. And just to make it even weirder, there's an x at the front. And there we go. That's what that function looks like. I guess I should just zoom into the piece that matters most. There. Would you agree this function has a problem at x equals 0 and only at x equals 0? Would you also be able to tell me that its left limit is -1 and its right limit is +1 and that its overall limit does not exist? That seems reasonable. You can't really tell from this, but can you trust me that f of 0 has a problem? In other words, the value of the function at 0 is undefined. And the reason why I'm pretty sure it's undefined is, isn't x to the power of -2 the same thing as 1 over x squared? And at 0, 1 over x squared is bad news, right? You're not going to get an answer out of it. So that would be that question. That was actually pretty quick, right? Some of them, the piecewise ones are fiddly, right? But if it's just a single function, just you type in what you see and then look at the picture and answer what you need to from there. So let's continue. Back to my notes. And the next group of questions involve us doing a sketch of a function when we're given some information about its limits. So let's suppose you are told that the limit as x tends to 2 minus of a function was 7, that the limit as x tends to 2 plus for that function was 3, and the value of the function at 2 was 5. And that's all you were told, and you were asked to do a sketch of it. So this is what I would be doing if it was my homework question. I'd say, okay, they're interested in 2, so 1, 2. The left limit as x approaches 2 is 7. So 3, 2, 4, 6, 8. Okay, there's 7. I would have that guy and I'd have my function maybe go like that. Would you agree that represents the limit is 2 minus is 7, right? Now, is that the only answer? No. Couldn't it come down the way to here? Couldn't it go along this way from here? Couldn't it be steeper? Couldn't it be shallower? But whatever your answer does, won't they all meet here? Now, the right limit is 3, which is about here. and the value of the function is 5, which is about here. And then you do in WebAssign is they give you 4 pictures, and one of them should sort of have the same features. It might not be exactly the same. Agree, couldn't we do slightly different versions? So can you pretend that when you looked at them, that WebAssign had a guy that looked like this? But, well, pretend my dot's a little bit higher. You see it's the same picture, right? It's the same information. So that's how you would tackle questions like question 12 and 13 and 14. And question 15 is quite interesting.
So what
Yes.
determines whether a like, you know how there's like the open circle and the closed circle? What determines which one is which?
Oh, these two guys here, I gave them both open circles. And the reason I did this is because they told me the value of the function. Now, if you know the value of the function, you're only allowed to have 1 point on a curve with any given y coordinate. So since that exists, these two have to be open, right?
So what about when you're like, when we were doing putting the function in Desmos and looking at the graph, how would we know which ones are open circles or closed circles when we're finding the limits?
That's a good question. It depends on if it's a piecewise function or if it was not a piecewise function. So when we did the one that looked something like this, and the picture we got, I might get it wrong, looks something like that, okay? We will make the assumption, because there's no evidence to say otherwise, that they're both open circles. And even if we made the assumption that one of them was a dot and the other wasn't, it wouldn't change the answer to left limit, right limit, or overall limit, right? It wouldn't change them. On the other hand, if you got a function that was a piecewise function, you know, the ones that would look something like this, and they might have x less than or equal to 1, maybe x from 1 to 2, and, you know, bigger than 2, that kind of thing. Do you notice that some of them have an equals on them and some don't? The ones that have equals would give you the solid dot. So I would be saying, right, at x equals 1, there's going to be a solid dot. So at 1, 1. At x equals 2, there's going to be a solid dot. Not x equals 1, but x equals 2 for this guy. So that would be at what, 2, 9, and nothing on this one. So you could find the solid and open dots on a piecewise very easily by looking at the boundaries, and the values that have the equals are going to be the ones that make the solid dots happen. Right? So you'll have a piece of curve and there might be a solid dot at the end, if that happens, or no solid dot if this happens. That makes sense? Right. So let's look at this fella. First question is, for what value of x is this function not defined? Well, they didn't tell me in the limit. I'm pretty sure I know. Would you agree that x equals 0? There's a big problem with this function. Because if you try to evaluate it, you're trying to find the sine of 0 over 0. But the sine of 0 is 0. And we do not like 0 over 0, right? 0 over 0 is, well, we have a catchphrase. We just say it's undefined. Undefined is a bit like us saying, I don't know, right? Later on, we may be able to find out at least what the limit of this is. And this limit could be 42, 0, 1, does not exist. Right? Now, if I plug this guy into Desmos, let's just so we can see what it looks like. And I'll move over and show you that. Come on, behave. Oh. It actually looks like nothing is a problem. In fact, as far as the eye can tell, at x equals 0, isn't the value of this function 1? Now, I've just noticed something that I've forgotten about in the past. Desmos is sometimes too clever for its own good. I'll tell you what I mean by that. This is what the picture roughly looks like in Desmos, right? And that guy there is 1. This is, in fact, what it should look like. Yeah, the overall limit's still 1, right? But shouldn't there be a hole there? Because 0 over 0 is undefined, right? There is no value to 0 divided by 0. But Desmos is kind of clever, and it knew what the limit was, 1. So it just decided to fill in the hole so it looked like a perfectly smooth curve. Now, strangely enough, if you do the exact same thing in your TI-84 and you zoom in, the TI-84 will put a low gap, which should be there, right? So that's what I mean by Desmos is too clever for its own good.
Professor,
Yes.
I believe in Desmos, if you hover your mouse along the curve, it gives you coordinates, and when you get to 0, 0, it should say undefined.
Oh, cool. Right, I'll try that. Let me stop this share and go back into that. Is there?
Yeah, it's supposed to, if you click on the actual line, you saw the
Right.
coordinates pop up there.
Okay, so if I click on this point, I'll get some kind of coordinate.
And if you go to 0, 0, it should say undefined or at 0. So, yep.
I'm trying hard.
Saw undefined.
Did you?
Yeah.
Okay. If you're really good and I'm not, evidently
zoom in
if you
even
click
more.
on it, it'll say undefined, which is nice.
Yeah, I saw it too.
I will take it back. Desmos isn't too clever for its own good. It's just too clever for me, right? So it did say what we wanted it to say, and that's cool.
Sorry for interrupting.
No, that is helpful. I think I always like to learn things. I think that is good. And so what you're going to look at here is a different approach to finding that limit. Hopefully, are you looking at a big table of values? We will make the assumption that this is in radians, which it will be. If you find the value of x at both plus and minus 1, the answer is 0.84. Now, as you notice, they're giving you both. I think it would have been easier to have a table with all pluses and the other table with all negatives, you know, just to separate them, but that's fine. Can you see as you get closer to 0, no matter if you go the left or the right-hand side, do you see that the value for sine x over x, isn't it becoming essentially 1? Right. And so you put in a 1 there. So let's move on to my notes and show you another way of finding limits, not by graphing them and looking, but by doing a table of values. So let's suppose I want to find the limit as x tends to 2 of x squared take away 4 over that guy. And I want to find the overall limit as x tends to 2. Well, what I could do is I could set up a table of values for this function. Have I got my calculator handy? I do. I'll go in here. Oops, first things first, make sure you're in radians. Almost didn't. Get out of that now. Well, it doesn't matter for this one, I guess. Clear this guy out, put a bracket in. X squared, take away 4, put in a bracket, x, take away 2. Why am I putting brackets in here? Why can't I just do x squared minus 4, take away x minus 2?
Order operations.
Yeah. If you don't, you'll just get something else. Right. Now, since I'm interested in the overall limit as x tends to 2, I might do a 1.9, and then I'll do a 1.99, and then finally a 1.39, and then a 2.001, a 2.01, and finally a 2.1. Can you see what I'm doing in this table? Is I'm approaching x equals 2 from the small side, right? Approaching 2, and from the bigger side, right? Approaching 2. And so we should be able to find these values, which I'm going to do using the table thing, which I set up before. So just clear out all this stuff, and I can just go 1.9, 1.99, 1.39, 2.001, 2.01, and 2.1. Well, for completeness sake, I'll write them down. Might be a bit easier for you to see. When x is 1.9, the answer to that fraction function was 3.9. When you get a little bit closer, it's that guy. When you get really, really close, it's that guy. Now, if you come in from the other side, you get a really close value. If you're a little bit further away, you get that. And a little bit further away, you get that. So can you imagine that what you're doing is you're approaching from both the left and the right? Conjecture. What do you think the overall limit is in this question? What would be a reasonable,
4.
sensible guess? Right. The funny little wavy lines just mean approximately or estimate, if you prefer. Does that make sense? Now, in a different question, right, a different function, remember that function that we had that looked kind of weird? I can't remember what this number is. Let's say it was a 4, right? Remember that one, right? Now, we know there's a problem at 0. So if I was doing a table of values for that one, since I'm interested in 0, I would be picking numbers like -0.1, -0.01, -0.001, and then start off kind of the other direction, going that way. Would that be a reasonable selection of x's, right? Converging in the center to 0. Now, if I can't remember this picture, and that might not be function, but didn't it kind of look like that, right? Now, what this table should do is it should show me the same kind of situation. So let's see if that's what we end up getting. So I'll go y equals, I'll do x times the square root, let's say it's 4 plus x to the power of -2, close the brackets. Go into table setup, just get rid of these guys, and put in negative 0.1, negative 0.01, negative 0.001, positive 0.001, 0.01, 0.1. And we got negative 1.02. That's kind of interesting. Let's have a look at this guy here. If you put your cursor over the answer, do you see you get a much more accurate version of it? So this would be negative 1.0002. I'm just rounding off a little bit. And the one underneath would be negative 1.00002. And then this one, positive 1. I think that's the right number of twos, then positive that one, and then finally positive that one. Now, can you see what is happening as you come in from the left and the right side? As you come in from the left side, would you agree the answer is negative 1? But if you come in from the right-hand side, isn't the answer positive 1? And doesn't that reflect, I probably got them the wrong way around, yeah, I did. But doesn't that reflect the jump, right, from one side to the other? Right? So actually, this picture should have looked like that, right? Left limit, negative 1. Right limit, plus 1. We call that process that you can actually estimate left, right, and overall limits by simply just doing a table of values. And there is a bunch of examples of that, but I'm only going to pick one because I kind of like the look of it. This is a version of question 20. And we're being asked to find the overall limit as theta tends to 0 of the sine of 3 theta over the tangent of 2 theta. Now, I could just plug that into Desmos and look at it, but sometimes it's hard to read the answer from Desmos if it's not a nice number like 2 or 3, right? Suppose the answer was square root of 3 over 2, right? Something weird. You wouldn't really be able to tell that looking at Desmos. The grade, it's not that good at being defined in such a way. Right, now the only change I have to make, and this time it is important that I'm in radians, is I can't do thetas, but that's not a biggie. I just pretend they're x's. So I'll go the sine of 3x divided by the tan of 2x. Anybody just feels lucky? Guess. What do you think that limit is? Doesn't exist. Overall limit doesn't exist. Nothing. 0. Right? No. 1. 42. Matthew, I'll put you in a spot. What number came into your head if it was a number?
Yes.
Say again, Matthew.
Oh, exist.
Oh, it does not exist. You could be right. I don't know. It's very difficult, isn't it, to just look at a function and figure out what's happening at a specific point, right, when x comes close to 0. Because I know it's going to be 0, right, sine of 0 over tan of 0, 0 over 0, which is bad news. So, second table set up. We're going to have theta, just to be consistent, and we're going to have f of theta equals to the sine of 3 theta divided by the tangent of 2 theta. And since I'm in control here of what values to pick, couldn't I pick lots of numbers? Or if I'm being efficient or lazy, whichever phrase you like, can I just pick some numbers? Just a few. Now, I'm going to be picking negative 0.1 and negative 0.001 and positive 0.001 and positive 0.1. And it's always a good idea, would you agree, that you should do either side of this number? Because couldn't it be up here at this place, but down here at the other place? Now, I'm going to go back in here, do the y equals, that's done, okay. Do the table, delete these guys.
Those are all the ones you had.
Did I?
Yeah, those are all those.
Oh, France, too late now. Got that one. Put that one in. And then put that one in. Right. So it looks like 1.4578. Technically, I'm pretty sure that's not 1.5, but it's darn close to it, right? This is 1 point. A lot of symmetry going on here. Right. What do you think the answer should be for the overall limit?
1.5.
I agree with you. And isn't 1.5 3/2? And do you see where that 3 and that 2 might be coming from? And I bet you, I don't have time, but I bet if you did the sine of 10 theta divided by the tan of 40 theta, you would get 10/40, which is a quarter. That's kind of cool, isn't it? That you might be able to use one answer to predict others. Any questions about what we've just done? Are we good? Right, well, if there are no more questions, let me just close off some windows. And why don't you do your attendance for a few moments? So type in your last name. And I'll want to just tell you a couple of bits and pieces, and then we'll finish for today. Okay, so hopefully you've all got your stuff in. Let me click on this one, do student view. There we go. Right, now, if you were interested, or maybe you for some reason missed our first lesson, or you want to find out how to do that Desmos stuff because you didn't have time to write down all the buttons that you pressed, you want to find our today's lesson, for instance. Right. Go to start your online math class here, Thingy Bob. And go to here. You click on that. And then week 1. And guess what? There's yesterday's lesson. So sometime probably this evening, it takes me a long time to actually do this. Half the time it doesn't take me time. I have to just like wait for half an hour or an hour to process it, and then another half an hour for YouTube to upload it. So it's not like I spend a lot of time, but I have to wait a lot of times. So this evening, you'll get our lesson here. Now, tomorrow is going to be a little bit different. You won't get Thursday's lesson here tomorrow. Tomorrow I have to leave pretty quickly after the classes are finished, so I won't be at home. I'm doing something, and so for that weekend. So what you're going to have to do only on Thursday is you're going to hit this guy here. Do you see Panopto recordings? That's where the unedited version, goes. So you'll click on that, I hope. Then you can click on that. And well, it should be in here. I wonder if it's because it's me. Because it's me, I have a different version of Panopto, but you should simply just be able to click on Panopto, right? And see our video for today. Right. or yesterday in this case. Does that do it? Let's try everything. Goodness gracious.
I don't see anything in there either.
You don't see it?
No.
Oh. What shall I do? Basically, the second my lesson is finished, I'll be going in the car and off with my wife, so I won't be here. I'm trying to think of how we can get tomorrow's lesson. Now, Panopto should be visible to everybody, so maybe I just need to look into it a little bit more. I'll tell you tomorrow how I fixed it, right? I've got around that problem. But that's only one time. It won't happen any other time. Just a special situation. Has any of you ever used the Panopto lessons in other classes, and did you find them okay? Is it just me being weird? Nobody's ever done the Panopto thing, right? Okay. That's some weird stuff. I don't even have this, so don't search everything. Oh, maybe I should just search Math 151. Oh. That's not me. Okay, I've kept you enough time. You've all got your thing. Bye-bye for now. I will see you tomorrow. I'll still be here tomorrow. I'll still be doing a lesson. You just might not be able to watch the video until after I come back, which won't be until Sunday. So I apologize for that. I thought it was going to be easier. Coral, what's your question?
Do you have a video about how to do the table graphs on a graphing calculator?
What, like the things we just did a few moments ago, Coral?
Yeah, like in your T84 graphing calculator, do you have video resources for how to properly like get the graph set up on there and everything?
The only thing I've got is actually what we did today. So if you've watched the video again, you can just pause, you know, at that point and watch what I did, and then maybe repeat it a couple of times so you can see it. I can show you a very short version, but maybe a little bit slower as well, of how I would do that. So if you're interested. Now, if you're not interested in this, guys, you can, you know, do your own thing, because I know your time's important. Right, so you go into y equals, and you put in the function, whatever it should be. So let's suppose I want to do a table of values for the limits of x minus 1 divided by x squared minus 1. Okay. So you type in whatever the expression is. So that's x minus 1 divided by x squared minus 1. So that's that bit done. Now, on the second button where window is, there's a guy called table setup. So you go blue button, table setup. And the only thing you need to do is to make sure that that guy says ask.
Okay.
And as long as that's asked, you don't go there again, right? It's done.
Okay.
And then lastly, you go to second graph, second table.
Okay.
And if there's answers from previous questions, you rub them out by just hitting delete. And we were interested, let's say we were interested in a table of values that were getting closer and closer to 1. So I might do a nothing point 9, then a nothing point 99, and then a nothing point 999. And then slightly bigger than 1, I might do a 1.001, a 1.01, and finally a 1.1. And each time I type them in, I just hit enter. And that is essentially your table.
Okay.
Now, if I look at this table really carefully, would you agree that as you approach the middle, aren't the answers trying to be a half, 0.5?
Yeah.
And so you would be putting in a half or 0.5 for that question.
Okay.
Did that help?
Yes, and then so I've never used the graphing functions on a graphing calculator before, only Desmos.
Well, okay, cool.
And so
It's really fun.
and so I guess I just didn't even know how to get to the where you would start putting in like your y.
Okay, you hit this button here that says y equals,
Mhm.
and then you type it in.
So I only need to do that then, and it'll
Yeah.
take me right there. Okay.
If you hit
Alright.
y equals, it takes you to here, and then you type in, sine
Okay.
EX, tan 2x, or what I've just written, and
Okay.
that's it done. And then, since we've already set up the table, you only need to go then second graph to get to the table, and then you type in the numbers you want for your table. And
Okay.
typically, you have to kind of rub out all the guys who came before.
Yeah.
So I would go up here and just hit delete until they all go away. And then you type in whatever your particular values here are, right?
Mhm.
Because sometimes the question will be 1.9, 1.99, 1.39s, and so on. So that's what I would be typing in here. And each time I type it in, let's pretend it was 1.9, 1.99, 1.999. Yeah, I would do it like that.
Okay. Yeah, that makes it easier. I was like, I see that we're graphing. I kind of get how to put it in the calculator, but I was like, I don't even know how to get there to start doing it.
Right, so the start doing it is the y equals.
Just
That's the
y
first thing you
equals.
hit.
Okay,